This Week in Virology, the podcast about viruses, the kind that make you sick. From Microbe TV, this is TWiV, This Week in Virology, episode 582, recorded on January 10th, 2020. I'm Vincent Racaniello, and you're listening to the podcast all about viruses. Joining me today here in New York City, Dickson Despommier.
Hi, Vincent.
On a week in New York City where it was hovering around 0.
Yes.
And now it's going to go up into the 20s over the weekend.
More.
Amazing. More? No, it's not
20s centigrade. That's right.
That's what I talk in.
Okay.
Yeah. Also joining us from Austin, Texas, Rich Condit.
Hi, everybody. How you been?
Hey,
Welcome
Rich.
back. Happy New Year.
Yep.
Thank you very much. We have an unseasonable, well, I don't know that it's unseasonable, but it's 72 degrees here.
Lordy.
But you know, it's we're expecting, there's a front coming through. We're expecting some significant storms tonight, and then the high tomorrow is 60. So, you know, that's what's going on.
Also joining us from Western Massachusetts. No. Also joining us from Southeastern Michigan, Kathy Spindler.
Hi, everybody.
Wow.
Here in Ann Arbor, it's partly cloudy, 45 degrees Fahrenheit, 9 degrees Celsius.
It's pretty mild, right?
Yeah.
It is.
And from Madison, New Jersey, Brianne Barker.
Hi, everybody. It's great to be here. It's pretty nice here, too. It's 7 Celsius, and it's going to be nice and warm this weekend, which is, just the perfect weather you want to stare at your computer and prep for classes to start next week.
Right.
It will test your resolve.
It will.
Don't go outside.
Right.
If you like what we do here on TWiV and all the other podcasts, I bet you didn't know we have TWIM, TWIP, TWiVo, Twin, and Immune. We used to have Urban Ag, but that's dead.
It's true. Well,
thank you for your enthusiasm.
It's languishing, but it's not.
Consider supporting us, microbe.tv/contribute. More on that later. It's happening with ASV, Kathy Spindler.
Pretty much like the same as last week. We want to remind everybody to pay your membership dues if you haven't done it, especially if you're a postdoc or student and you want to apply for a travel award, you have to be a member. And if you are submitting an abstract, you need to have a sponsor and they have to have their dues paid up. The Global Virology Scholar Travel Awards are due on Monday, so unless you're listening to this promptly on Sunday and get your act together, it's almost too late. And we do have early decision for abstracts. You can submit your abstract before the deadline being January 31st at midnight. Submit your abstract before that if you want to start the process for getting a visa letter. And all the instructions for that are on the Colorado State University ASV 2020 website. That's asv2020.com.
2020, love it.
Mm-hmm.
I really like that.
Has anybody seen any of Bloomberg's ads? Political ads?
Mm-mm.
He's got a wonderful way of expressing 2020. He's got the first 20 is red and the second 20 is blue. So no matter who you are, there's nothing in the middle. However, there's nothing for independent voters.
Say 2020 as opposed to 2020.
No, he just wants to cover his ground here. So he's getting Republicans and Democrats. He's not going to distinguish. He's just going to say, vote for me.
Okay. And we have a follow-up from Dirk Chalkmans. Maybe we can add Nobel laureate Gertrude Elion to the list of female virologists. This is our conversation last week. As far as I know, she was the first to describe a direct antiviral, acyclovir. There also exists the Gertrude Elion Award, which is the highest award in the field of antivirals. Thanks for the great podcast. Dirk is at the University of Leuven.
That's nice to know. I didn't know that about her.
So I went to the website of the International Society for Antiviral Research to look at the awardees. And this year's is Anne Kwong, which is great. Because there's only one other woman in the previous 20 years who would be Karen Byron. So I know Anne I was on committees with Anne. She's an amazing antiviral person. She's in the Boston area. She knows so much about antivirals. That's what she does. It's great. So I think this is probably a good selection here.
Neat.
Yeah. And also last week, Vincent mentioned his list, and it had Hershey and Chase on it.
Mm-hmm.
And it was after that I realized that the Chase in his list is Martha Chase. So there's at least one woman on your list.
It is. It is indeed. Martha's there. And everyone always says the Hershey Chase experiment, right? So.
And I just wanted to add that the development of the embryonated egg as a tool for growing viruses happened in Ernst Goodpasture's laboratory, but the woman who actually did the work was Alice Woodruff, who I believe was an assistant at the time. But he said, "You do this," and so she did.
Cool. Kehaluani writes, Aloha. I'm listening to the discussion on TWiV 581 and have a few comments on the role of the gut microbiome. Vincent is correct about the change in our diet from early human ancestors that ate very little meat compared to modern humans. Studies have been done on gut diversity and have found to be more, I don't know how to fix that. To be more species rich in humans that have a diet thought to be similar to our primitive ancestors. Provides a link to an article on that. Gut microbiome of the Hadza hunter-gatherers. I almost said Hadza, which would be very different.
True.
I don't know how many. Current studies on brain development suggest that it is thought to be less related to meat consumption and more about starch digestion, whether it was the use of fire to cook starchy tubers and make the sugar more available on the increase of starch digesting enzymes. And it gives another link to an article, which is, did eating starchy foods give humans an evolutionary advantage? It brings me to mind this recent paper where they got some substance that someone had chewed many, many years ago.
Gum, like gum.
It's like
almost.
a gum-like thing.
Yeah, they said it was gum.
And they got DNA out of it. And they could sequence a lot of the genome from the saliva that was impregnated.
Can you believe this stuff?
It's great. It's wonderful.
You can't make it up, that's for sure.
Yeah, that's very cool. And then the increased role of meat in our diet is thought to increase specific species of gut bacteria that are associated with chronic diseases such as heart disease, kidney disease, diabetes, and many others. One compound that might be causal is TMAO, trimethylamine oxide, which is created by specific gut bacteria upon digestion of compounds found in animal products. I would love TWiM to discuss one of the many studies on TMAO in the literature. I'm a PhD nutrition student, and I'm hoping to do a study looking at this compound and disease outcome. Atherosclerosis is one of the first diseases linked to a high meat diet and elevated TMAO levels. A recent study of a mummified Inuit showed signs of heart disease in a population known to eat a meat-based diet. Another link to that. Thank you for these excellent podcasts. I have been listening since episode 1 and really enjoy your discussion on all the Twixes. Mahalo Kehalwani. Thank you. Thank you very much.
Nice.
Well, I wonder how many people are out there who've listened since episode 1, especially TWiV. I mean, that's a long time.
Yeah.
It is well.
It is a long time.
What was I going to say? Oh, I had something. The grain of an idea or a comment.
Is that a pun?
I don't know. I can't. I've lost it. That's how it goes. It's fine. Dickson, want to take the next brief one?
Ryan writes, Dear TWiV, here's an Orbit A. Bennett Jensen.
Obit.
It's an obit.
Guy died.
Here, let's take this up again. Here's an obit. A. Bennett Jensen, one of the leaders in the HPV vaccine development, has died. Sad to hear. And he gives a link to that. And you want me to read the next line too? In Vincent Racaniello's home state?
No, not yet. We're going to first talk about Bennett Jensen. Right?
Sure.
Mm-hmm. Who I'd never heard of.
I don't know him.
Credited, one of 3 people credited with HPV vaccine. So let's look this up because I didn't know this.
I did. I looked it up.
What do you got?
Basically, he was one of 3 individuals. Him, his wife, and the other person whose name I'm not finding right now, who were at Georgetown University at the time, who did some of the final development that led to the commercialization of the HPV vaccine in the form of Gardasil, GlaxoSmithKline. Okay, there was a lot of research that led up to it, but those three are credited with doing the work that finally led to its production as a vaccine.
Okay, good. Not that he died, but good that he did that.
Right.
Yes.
Great.
I have a link to an article for two reasons. In my home state, it's an article in the Patch. New Jersey ready to pass bill removing religious vaccine exemptions, which is great. Okay?
Yes.
But the one
It
thing
is great.
I wanted to point out is that there's a picture here of a line of parents lining up to protest, which I'm thinking, what are you thinking about? Why do you need a religious exemption to a vaccine? First of all, point to me the scrolls, the scripts, the information from wherever that says you can't.
They don't exist.
They don't exist.
No, they don't.
I mean, this is crazy. There's
They're
no
making it up.
scientific basis. And why are these people? I'm looking at these people. They look like normal folks I would see anywhere, right? With their kids and everything, but they want a right to choose. I just crazy. And someone says here, oh, they're responsible for chronic diseases, and so we don't want to give them to our kids. This is just crazy. What did the guy say? Gasoline is flammable. The earth is round.
And vaccines
work, and everything else is lies.
That's right. That's right.
Oh, that was last week.
Yeah, you missed that one, Rich.
I just don't get, what are you people fighting?
We've got if we get to it today, there's a letter coming up in the email that has a link to a NBC News article that's really outstanding. Okay, that gets under the skin of a lot of this anti-vax stuff.
You can make
it's really annoying.
You can make the same criticism over people who refuse to wear headgear for their motorcycles. They got outraged when that law was passed. So that's why they came up with this German helmet shape to sort of protest in without having to break the law. But they'll protest anything. It doesn't matter. They don't want to be told what to do. Period. They just don't.
Well, they have
the problem. The problem, it seems to me, is that if you don't want to wear a helmet, fine, you're an organ donor.
Really?
Great, but it doesn't necessarily kill somebody else.
Yeah.
Okay.
Exactly.
The whole vaccine thing.
Understood.
The anti-vax movement.
No, but the attitude is the
kills
same.
innocent
The
people.
attitude is the same, though.
But I even have a problem with the not wearing the helmet. You might not die, and then you'll be on
that's
the
right. That's
Right.
insurance and all that
That's
other
correct.
stuff
That
for
is
your
correct.
brain damage.
Right.
You got it.
True.
You got it.
So here's one of the parents. She says, whether you're a pro-vax or anti-vax, the decision to vaccinate your child or not is your choice.
No,
This is taking away my constitutional rights. No. The right to follow my religion. Well, that's BS, because there's nowhere in your religion where it says you can't vaccinate your
Correct.
kids. I'm sorry.
That is
That's
correct.
just BS. You're using that as an excuse. When it comes to public health, you can't have a choice. You have to follow what everyone thinks is best.
And you don't have a right to do anything you want. You don't have a constitutional right to kill somebody.
That's true.
Okay, we
Yell
make
fire in a
laws
crowded
to
city.
protect people from harm. Okay.
That's right.
Okay.
Now we're getting fired
So
up.
now we're going to hear from Ted Bundy, who wants to say something here.
So we have apparently a new virus in China causing a pneumonia-like illness. Just between this episode and last, this seems to have hit the news, right?
Popped up. Just
I mean, last Friday, I didn't know anything about this.
Mm-hmm.
So there have been many articles all over the place. First, apparently this has been happening in December, end of December. Something like 59 people in Wuhan, China, which is, I got a little map here because I wanted to see where this is. Looks like it's sort of halfway between Beijing in the north and Hong Kong in the south, due east or due west of Shanghai, right?
right.
Mm-hmm.
Yep.
I've never been to China.
Oh, yeah, but Wuhan is a pretty big virology place.
It is, yeah. And so 59 cases of people with pneumonia-like illness. No deaths so far. High fever, difficulty breathing, lung lesions. And apparently early on they ruled out SARS coronavirus, avian influenza, MERS coronavirus, adenovirus. Now, apparently they closed down the Huanan seafood market, which is in Wuhan. There you can not only buy seafood, but poultry, pheasants, and wild animal meat.
That's Hunan, by the way.
I wrote it Hunan, but I've seen elsewhere Huanan.
Oh.
I'm not sure which one is right. They said a number of cases were traced to it.
But Wuhan is inland from the ocean.
Yeah,
so other fish markets must be involved in this as well. They don't just ship fish to
Huanan works too. You get a Huanan, and that is in Perth Amboy, New Jersey.
Really?
It's not the same one. Yeah, Huanan. Here's a Taiwan news article. Huanan is correct.
Oh.
So I had it wrong there.
Oh.
Okay. And then, interestingly, there's been, China was a little bit quiet about this, and usually they weren't sharing.
Just like SARS.
They have a quote the other day, I think this was in the Times, from Lin Fa Wang, who I saw in Singapore not too long ago. He said he was frustrated that scientists in China were not allowed to speak to him about the outbreak.
Huh.
And Lin Fa said he thought it was likely not spreading from humans to humans because health workers had not contracted the disease. He's quoted, "We should not go into panic mode." And then they're online, the authorities have clamped down on discussion. The hashtag Wuhan SARS has been banned,
Lord.
For example. Hong Kong Airport, they've put thermal imaging in place. Now, Kathy has a map here. Huanan, right? Is that Wuhan? Yeah, there it is. Isn't it so cool? You can get a map of anywhere in the world
I know,
now.
it's amazing.
Oh, what's
You can go to Google Earth and actually see what it looks like.
Yeah, there it is, the seafood market right next to Wuhan Rural Commercial Bank. Okay.
Cornered from Hubei Bank.
Yes. So it's a funny combination. Fish, pheasants, poultry.
Are they saying 59 different people visited that fish market?
Well, we don't know. See, we have very little information, right?
There's no.
However, apparently the authorities seem to think that this could be a source of a problem.
Yeah, apparently it was shut down and decontaminated or whatever. I mean, frankly, they should shut them all down because that's a good way to get exotic viruses, right?
Mm-hmm.
But it's part of their culture, and I understand that they don't want to. Who's going to tell me where to buy my food?
Exactly. No one can tell me where to buy.
I mean, as you'll see, the problem is that if you're going to collect wild animals from the countryside, they could have exotic viruses in them, right?
You bet.
And yesterday, the news had it that it is a new coronavirus. And if you go to ProMed Mail, you can see some discussions there. They have a quote from someone involved in the investigation. While it appears to be transmitted to humans via animals, the Chinese government has not said which animals, nor has it disclosed other details about the outbreak, like the transmission route, the incubation period, or the ages and genders of the patients. Authorities in Wuhan are closely monitoring 163 people who were in close contact with the patients. He added that 15 days is the minimum incubation period for some viral infections. I don't know where that comes from. 15 days is a long time. I mean, some viral infections are 2 or 3, right?
Yeah.
It's true.
Had not yet passed since the last reported instance of the disease. Premature to say there's no human-to-human transmission. So if you go to ProMed Mail, you can see they apparently got the whole genome sequence. And so they can make PCR assays now for it. Although it's not clear from how many patients they have this virus yet, right? We just don't know.
What's the closest next virus to it?
They say it's a brand new coronavirus never seen before.
Yeah, but it can't be that different from some of the other coronas, right?
Exactly. It has to have, you have to put it on a phylogenetic tree.
Yeah, exactly. Yeah, right.
I mean, because we know that people have been looking at bat coronaviruses in China. And of course, they've been looking mainly in the South, I believe. It's where SARS originated. But maybe this is similar to one of them, right? But we don't know. They're holding that close to their vests. Is that what we would say?
Yeah.
Yeah.
They seem to be treading a fine line here. They got roundly bashed for keeping the SARS epidemic quiet for too long.
Yeah.
And so they seem to be a little more open about this. On the other extreme, they don't want to foster panic.
Yeah.
And then it's also China.
It's
Okay,
China.
so-
Yep. Guan Yi, a professor of infectious diseases at the University of Hong Kong, who was involved in identifying SARS coronavirus, said, "We can assume this virus transmissibility is not that high." I don't know if you should assume that yet. Who knows?
Yeah.
So it seems to be a new coronavirus. Okay, because the guy on ProMed Mail said that. And I would guess it's a zoonotic infection, right?
Mm-hmm.
Yeah.
It says if it's associated with this meat market, it's probably an animal that was shipped in from the yonder.
Yep.
Has virus in it.
We think it's a seafood market.
It's a seafood
Yeah,
market
but
that
they've
also
got
sells
With
meat.
birds and stuff
Yeah.
there too. Yeah.
Right.
I would be really surprised if this came from fish.
Yeah.
Right.
That would be something.
Yeah.
According to Brianne, she's having computer issues. So if they have, the good thing is if you have a PCR assay, now you can start looking in people who are sick and maybe healthcare workers who have taken care of them, right? And you could start seeing who's got it.
Right.
And since now the world has experience with these outbreaks. All right, she's having, her computer's non-responsive and she's trying to figure out, so we'll just continue for now. Sorry.
You should give it mouse-to-mouse resuscitation.
That's funny. Dickson.
Ooh, that's good.
Did you just think of that?
Yes.
You have never said it to anyone before.
Not in this context.
So this is going to be a rapidly developing story, I think. Don't you
Yep.
think?
Yeah.
It's kind of interesting.
Yeah. And as I noted in the show notes, we had John Dye here yesterday as our seminar speaker. He was on the Prometheus Project TWiV 578. You might remember him as the person who was a son of a military person, and he wanted to serve his country but not be in the military. So he's working at USAMRIID. Anyway, afterward, I went up and talked to him about a couple of things. And the last thing I asked him was, who did he think would be jumping on this coronavirus in China? Would it be somebody from the Prometheus Project? And he said, well, probably Kartik.
Yeah, John is great. I enjoyed him. I said to him, you have a nice military haircut. And he said, thank you, sir.
Yeah.
So remember SARS? Does anyone remember?
I do. I got a free trip to China because of that.
How's that work, Dickson?
They invited our entire Department of Environmental Health Sciences over.
Wow.
And we went and we listened. And the 2 weeks after that, they fired their entire public health department.
Where?
Ooh.
In China.
Well, what was it?
Why? Because they invited you?
No. It's because they were guilty of holding back information and allowed the epidemic to spread without identifying the source.
They did hold it back for a long time, and that's not good because these things spread globally, and other countries need to know, right?
It was a big tourist area, and during the summer,
you want to censor your own people, that's your own business, but it's something that's going to travel. You can't keep that in. And they seem to be holding back a little here.
See, viruses have no borders either.
They don't. They're parasites without borders.
That's right.
So anyway, in 2013, that's when SARS emerged. It was in the south, the Guangdong province, I think.
Yes.
You said 2013, but you meant 2003.
2003. I'm getting old. Gosh, I don't even know what I'm saying. I have to watch out. I could be elected president. Oh, I'm sorry. Eventually spread to many countries. Over 3,000 infections and 774 deaths.
Yes.
And there, the source was the live meat markets, and the meat probably had bat contamination in some way. It was initially linked to palm civets.
That's right.
Which may have been contaminated in the countryside. Anyway, it's a bad origin. And since then, people have been looking for similar viruses in bats in China, and they find them. They're circulating without question. Mm-hmm. Go back to TWiV 538, an Iowa caucus of viruses, to Stanley Perlman talking about why that particular outbreak fizzled out. Hey, we are coming on the Iowa caucus, aren't we?
We are.
Mm-hmm.
Wow.
I know.
That was a good name for that podcast. Then, of course, in 2012, MERS coronavirus emerged in the Middle East. Goes from camels to people, but probably the ultimate origin of that was bats also. I like to say that before 2003, these coronas were just, sleepy viruses, caused common colds. A few people worked on them. They didn't get paid much attention to. They had big RNA genomes. But then in 2003, it changed everything, put a lot of attention and a lot of money into coronaviruses.
What's changed everything is sequencing.
Yes, it has.
Okay?
Yeah.
Because, people used to die of respiratory illnesses that were basically undiagnosed. A lot of that went on.
Yeah, sure.
And so this stuff has been going on for a long time, but now we have much better methods, mostly due to sequencing, for diagnosing what's going on.
Right.
So there have probably been coronaviruses causing acute respiratory illness or maybe even minor epidemics for a long time. But now we know how to identify them.
So I wonder, SARS 2003, right? You get an outbreak in China, then you get outbreaks in other countries. If this happened 100 years ago, would nobody even put the two and two together?
Forget it.
Probably not. No.
That's right.
Yeah. I mean, it's also
And if I recall, the way SARS burned out was mostly people understood what it was and took appropriate public health measures, right? Quarantine,
yeah, that was part of it. And Perlman said basically it's not very infectious. It doesn't transmit well. So if you do a little bit of infection control, you got it, right?
Okay, so if you have maybe a lower population I'm talking 100 years ago, lower population density, and something like this flares up, it probably burns out pretty quickly.
Yeah.
And people say, "Oh, that was unfortunate," but that's kind of the end of the story.
There was more illness a long time ago, and people say, you got
that's
sick.
Right. This would be background.
However,
people were dying of smallpox.
There were fewer people also, remember? So, you had significantly fewer people 100 years ago.
Mm-hmm.
So
yeah.
Maybe you didn't have this because the ability to transmit from person to person wasn't there. This is not a person-to-person disease. So,
right.
And with more people, more food items appear on the table because the standards become relaxed because the standard food items become more rare. So where the hell did palm civets fit into the diet of Chinese?
Yeah, well,
they're raised on a farm. I know that they're farm raised, but
they like to eat them.
I understand that, but they're so cute. If you can take a look at them, How could you eat an animal that looks like that?
Cows are cute.
No, they're not.
Yeah, some people think pigs are cute.
Yeah, pigs are very cute, especially young.
Yeah.
Mm-hmm. I feel badly about eating cows and pigs now.
You do?
Yeah, I don't eat them anymore.
Oh.
No, I just can't. I mean, it's my own choice, but I feel very badly, and I think it's also not good for the environment to make that methane.
Mm-hmm.
If I can, I have a Beyond Burger or whatever, Impossible Burger. Those are delicious.
Impossible Burger, right?
Back in TWiV 364, it's not SARS 2.0. We had Ralph Barrick and Vineet Menachery to talk about. They took some of these SARS-like viruses circulating in bats, showed they could infect human cells, they could cause disease in mice, and they got a lot of hell for that work, saying that they were endangering the world. But in fact, you need to know this. You need to know that these viruses have potential to infect humans and human cells. So there you go. We will probably we're not going to record on next Friday, but we'll certainly be back in 2 weeks to talk about this.
Revisit this, see what happens.
But next week, Rich, I will release our first episode in Galveston, which is probably good timing, right?
Yep.
The virus discovery with some people who've been doing this for a long time. Speaking of respiratory illness, let's talk about influenza. Did you get a flu shot, Dickson?
Not yet.
Okay, so last week we touched on this briefly, but we promised to go in a little more. So you can go to cdc.gov/flu/weekly and /usmap.htm if you want and see what's going on. It's a really great resource, maps and so forth. So you can get summaries of what's been going on. And so basically right now flu activity is quite high. The U.S. is peak season for influenza, and it will be for a few more weeks. They have distributed 170 million doses of flu vaccine.
Wow.
So far. It's a lot of doses.
Wow.
That's about half, potentially half the population.
Mm-hmm. Yeah, that's about right. So someone asked last year, I think it was you, Dickson, because you often throw out questions. How's the vaccine doing?
Yeah, I actually might have said
And
that.
in fact, see, if you go, you can say, there is a question, how's the vaccine doing? And the answer from the CDC, we're not ready to say that. We don't have the effectiveness estimates. It's still too early. And they're depending on epidemiologic studies which compare illness in vaccinated and unvaccinated people, right? So they'll be available later. And then they say, we do have some lab data and antigenic characterization, which are updated weekly. And right now, the most common circulating viruses are influenza B Victoria and A H1N1. If you look at the graphs, you can see most of the isolates are B viruses. And I don't think that always happens. It's very, very interesting. Antigenic data collected up to now suggest a very good match between the circulating A and B viruses and the vaccine. However, the influenza B Victoria, so there are two B strains, B Yamagata and B Victoria. B Victoria and AH1N1 are the most common circulating viruses, but they say the B Victoria and AH3N2 viruses show reduced similarity to the vaccine viruses. But I don't think that matters so much because they're not the predominant circulating strains this year. If they were, then it would be an issue. Okay. And so I'll put a couple of links in, like weekly surveillance graphs, which you can see what's going on throughout the country. I think they said somewhere that the illness is not any higher than in recent previous seasons. So it's not it's not a season of excess flu mortality.
It's interesting, however, if this map resource that you linked to is really quite something, because you can look at past years.
Yeah, it's great.
And you can also click on individual states and get the state health report.
Mm-hmm.
And as I click through this, most of the states this year, that's for the week ending January 4th. It's not a summary. It's not a summary for the year. If you look through previous years, I mean, because it's widespread everywhere. The same week in 2019, we're talking sporadic everywhere. I mean, it looks like for this week, it's a heftier year than the same week in past years, but that doesn't tell the whole story. Okay.
Yeah, you can.
There's a lot of things you can do.
There's a ton.
Yeah. It's an amazing.
So you look, the first graph is influenza positive tests. And these are reported to CDC by U.S. clinical laboratories. So there's a lab network throughout the country, and they, get people with suspected flu. They do a nasal wash and do a test and report it to CDC, and they tell them it's either A or B, and then CDC further differentiates if they want, or they ask them to. But you can see here we go by week. It seems to have peaked in week 52 of last year. And now this first week seems to have gone down a bit.
Oh, yes, I see. You use the slide bar to change the weeks. Yeah, up above the map.
Right.
Yeah.
You can see how many specimens have been tested. So cumulative since September, they've looked at almost 500,000 specimens. And only 13% of those 64,000 are positive for influenza. So a lot of respiratory diseases, other stuff, right? You can look at, the subtyping, which is the next graph, and where you can see that B is pretty big this year. And then you can look at sensitivity to antivirals. And right now, there are 4 antivirals that are recommended. Oseltamivir, Paramivir, Zanamivir, and Epiloxavir, and there's no resistance yet to those. She's out for today. I'm sorry.
Oh, gee.
No, that's too bad.
Yeah.
Oh,
Sounds like the blue screen of death.
Exactly.
Yeah.
bad. I always have 6 computers around, so if one breaks, I have more.
So I take back what I said about this season looking worse at this time because I wasn't understanding the graph right. If I go back a year, and as Kathy suggests, use this little slide bar to go through the weeks, that's fascinating because you can see the season progress and then peak and then fade out. And, like last year, there was a time in like week 6 or so, 5 or 6 of the new calendar year when flu was widespread everywhere in the country last year. So similar to what we're experiencing now this year.
So there's, go ahead.
Interesting.
I was just going to say, I'm looking at a graph where in 2018, there's a huge peak in the 3rd week of pneumonia and influenza deaths.
Oh, yeah, that's the...
at or above threshold, the red line graph. Wow.
Yeah, that was a big one. So this year we're kind of below the epidemic threshold.
Yeah.
Which is usually the case. You're usually at. Yeah, that year was a bad one, yeah. I'm looking at the percentage of visits for influenza-like illness reported. And they have lines for years going back to 2009. So 2009 was a big one because that was the pandemic year. And then some years it's very low. And this year it's very high so far. It's the red line. It's kind of creeping up on the 2009. So there's a lot of influenza-like illness.
And peaking, well, I wouldn't say earlier than average, maybe a little early.
Sometimes it depends. Some of the peaks happen there, but then there's another spike later on.
Yep.
Right, in say the second month of the year. So it can just stay down. In some of those other years, it peaked in now and then it went down. So it varies from year to year.
The 2009 pandemic, that was real early. That was a very different early story.
That was totally different. Yeah, that happened.
Is that the one from Mexico?
Yep.
Yeah. Yep. That happened in the spring.
Yeah. And
yep.
I remember saying, that's not going to amount to much. That can't be really serious. And I remember my line was much ado about nothing. Here. Ha, ha, ha.
Week 42. Yeah, it was much ado about nothing. We were wrong.
Absolutely wrong.
Yeah.
We were wrong.
Well, I first heard about it when I was in Budapest and turned on the TV and saw this, thing. And it was like, oh, here I am in a foreign country. And
right.
Yeah.
What was last year's strain, by the way, just for...
Strain of what?
Of influenza that swept through our country last year.
I think last year was predominantly H3N2.
Okay.
So this year's it's B and H1N1.
Could you refresh, by the way, also for the listeners that are not quite up to their influenza biology, A and B, we are talking about reservoirs in birds rather
these are subtypes, A, B, and C, right?
Right. They're all found in birds.
No, A is found in many animals.
Including birds.
Yeah. So the reservoir is water birds mainly, but they're in many other animals.
Oh, okay.
And they spread to other animals from birds.
Right.
But they can infect humans, domestic animals, pigs, horses,
B?
dogs. B, to be or not to be.
Indeed.
B is, initially thought not to have any animal infections, but there's some evidence that they are, but not to the extent that A.
It's mostly birds.
A undergoes, pandemic reassortment, and B doesn't seem to. B seems to just drift.
Okay.
And C, nobody worries about. Apparently, it's not in the vaccine. It seems to cause asymptomatic respiratory infections are very low.
All right.
So the B that we know, the primary reservoir is humans, right?
Yeah, that's right.
Okay.
The other measure of lethality is influenza-associated pediatric deaths. This is a reported statistic, and they have a graph showing this for the previous seasons. And this is not huge. Like in 2018-19, there were 143 deaths. This year so far, there have been 32, so maybe a milder than usual year in that sense as well. Anyway, the CDC for the U.S., now I'm U.S.-centric, but many other countries have similar data reporting in their health authorities, and you can find them. You can just search for them. And I don't mean to exclude them. Of course, if you're in the southern hemisphere right now, you don't have a flu season, right? Because it's summer. Right. Summer there. But you have other problems like your country is burning.
Wildfires.
Yeah. So let's see. Yes, so
The lack of a caring government.
A couple of points here. Flu is high nationally, yes. B. Victoria are predominant nationally, which is unusual. Okay, 6.4 million illnesses so far this year, 55,000 hospitalizations, and 2,900 deaths. So for those of you who say, I don't get the vaccine, people die. People do die.
Yeah.
And young people may die, too.
You talk to me Monday, and I will have been vaccinated.
We just talked about 300. I can't remember what number you said of children that have died this year.
32.
And there are certain children who cannot be vaccinated, and we need the herd immunity to prevent them from getting flu.
And there's no downside from the vaccine.
There's no downside.
No.
And then it's not too late to be vaccinated.
Yeah, and Vincent, you said your arm was sore for a day. My arm is never sore. Yeah. So
it depends on the amount of inflammation. I think soreness is a good indicator that it's taking.
Yeah, absolutely. I one time in the last 10 years or so, one time I got a minor cytokine storm. I felt malaise.
Interesting.
For very shortly after the shot that was over within 24 hours, and I figured that was my immune system really cranking up. So I called that good.
So the day after I had the flu vaccine, this is back in the second week of December, I went for a checkup, and he gave me a pneumococcal vaccine in the other arm. And that was sore for 2 or 3 days. And of course that has multiple, I don't know, is it a carbohydrate?
It's like 9 the first time, and then 23 with the booster or something. Yeah. Strains.
Antivirals. Almost greater than 99% of the viruses tested this year are susceptible to those 4 antivirals. I mentioned that. And 3 of them are neuraminidase inhibitors, and 1 is an endonuclease inhibitor. Dickson, for $5, can you tell me which one of those 3?
It's not enough money. I'm sorry. I can't pull that up for that much money.
For academic interest.
Oh, brother. What are you asking me?
Which of these 4, Tamiflu, Relenza, Peramivir, or Epiloxavir, which is an endonuclease inhibitor?
I feel like I'm on Jeopardy.
Well, 3 of them are neuraminidase inhibitors.
Hey, Dickson, I'd be guessing as well.
I'll pick Tamiflu.
You could read the show notes. It's written show notes.
Oh, gee, that would be asking.
If I ever learn how to read, that would be good.
Yeah, Epiloxavir is the endonuclease.
Epiloxavir.
It's a very recent one, just approved in 2018.
It was made in Biloxi, Mississippi.
No, it was developed in Japan, actually. Okay. But, the endonuclease is a viral enzyme needed for RNA synthesis. And so they looked for an inhibitor, and this is great.
Why doesn't this work against all of them then?
All of what?
All the flu viruses.
Well, it does.
All the strains.
It does. It works against all the A's, I'm pretty sure.
Okay.
I don't know if it's a good question if they work on B viruses. Let's type that. Does Epiloxavir
for $10
block influenza B? Let's see. Yeah, A and B. I love it. I really like that you can ask questions. All right, so all this B, so B is important this year. It's predominant, and it reminded me that many years ago on TWiV, we had a contest where we had people write a short essay to win a book called Viruses by Marilyn Rusink. Oh. And one individual wrote this wonderful essay he worked on influenza B. And he used the capital B throughout his essay.
That's right.
Oh, I remember that. Yeah. Yes. Now I get it.
And he won. Okay. He won the book.
Yes.
So when I went to Singapore, I went to the National University to visit. I was having lunch. Well, he actually came up to me at the NEPA meeting with his book. And he said, I won this years ago. I want you to sign it. And then
he didn't write the book.
He came to lunch the next day.
Right.
No, I didn't write the book, but he's the one who wrote the influenza B essay. Right. And I said, that I remember because it was so clever. And he said, I think that's the best thing I've ever done. So I couldn't find his email by searching, but if you're listening, it was great to meet you. And that was such a cool, and this is influenza B year, apparently.
Outstanding.
Now, in line with influenza, we have an email from Amal, and maybe Kathy, you could read that for us.
Sure. Dear TWiV hosts, I was surprised to find out that individuals who have been vaccinated against the flu may still get infected without getting sick and have viremia levels that would allow transmission of the virus. If this is true, I do not trust my source, and there were no clear answers in the papers I read about this issue. If this is true, wouldn't that mean that making vaccination mandatory for healthcare workers in order to protect their patients is basically a useless recommendation? I mean, it is useful in the sense that healthcare workers will be protected and able to work in case of an epidemic, but there is no protection for patients? In that case, shouldn't it be the opposite? Not recommend flu vaccination for healthcare workers that are not susceptible to complications caused by the virus and illness, so that they won't be asymptomatic. Not that only vaccinated individuals could be asymptomatic, but I imagine it to be more frequent among those who are vaccinated, and therefore they won't risk transmitting the virus to patients that much. If this is true, is it applicable for all vaccines? Thank you in advance for your answers. Best, Amal.
I thought it was important to address this. I spent a good amount of time looking into it because it's an interesting point, which I haven't really thought about before.
I also want to comment that Amal says, in parentheses, I do not trust my source, and there are no clear answers in the paper. Okay. Mm-hmm. And the rest is, nicely reasoned, hypothetical stuff. So basically, he's got a legitimate question here, and he's going to the expert.
Yeah, it's a great question, because if you what he's saying could be an issue if there are asymptomatically infected people who can transmit, and that's the question.
Right, okay? Big if.
So first thing is, there's no viremia involved in transmission. What's involved in transmission, of course, is virus and respiratory secretions. Right.
So explain what you mean by viremia. Virus
in the blood. So Amal wrote, people who have viremia levels that would allow transmission, but it's not how the seasonal flu doesn't make a viremia. You could.
He may not actually mean viremia.
Maybe not.
He'd be talking about virus load generally.
Right. So it's virus load and respiratory secretions that we're talking. Just to be sure, okay.
This reminds me of my my ancient pathology lectures. There are some viruses that enter and exit essentially from the same organ or tissue, like flu. You get a respiratory infection, you expel the virus in respiratory secretions. Others spread by various routes, including the blood. Flu doesn't spread in that fashion.
Right.
No. Neither does rota. So you get that one early, and then you can transmit it via.
Now, let me just say that if you took a person with influenza and took blood and did PCR, I bet you could find some viral RNA.
Oh, yeah.
But I don't think you would find infectious virus, and that certainly does not contribute to spread.
No. RNA is almost as bad as DNA. There's DNA everywhere. It's really a problem.
So we have this view of, in fact, the pathogenesis of infections was, influenced by early people who didn't have sensitive techniques for looking for nucleic acids, right? They look for infectious viruses. Influenza, there's no viremia. And they were right, but the virus could get in the blood because you imagine tissues get damaged and so forth. Anyway. So the bottom line here is that influenza vaccines, especially inactivated flu vaccines, do not reliably prevent transmission. But mostly these are symptomatic people or minimally symptomatic people who are transmitting. And flu mist appears to give you better immunity, what we call sterilizing immunity. Okay? Sterilizing immunity is complete protection from infection. All right? You have immunity, a virus infects you, it doesn't get anywhere because of immunity. So that's what we call sterilizing.
Because you're immunizing in the same route that you catch the infection in.
Well, for flu mist, we are.
Right.
Plus, you're probably inducing a more appropriate immune response because of the route of administration and because it's a live vaccine.
Right.
Correct.
You also induce cellular immunity, which is important for that. Now, but a great example is the polio vaccine. We have two of them.
I was just going to
We have an injected vaccine we have one taken orally.
That's right.
The injected vaccine does not provide sterilizing immunity because the virus can infect your gut and multiply and spread. Spread.
Whereas
the oral vaccine does give you sterilizing immunity. It blocks gut replication.
Because that's how you acquire it to begin with.
And that's how you acquire it. Now, in my research, I found out a couple of interesting things. I read this review article, which I will link to. It's open access on flu vaccines and sterilizing immunity. The gold standard is sterilizing immunity, and it remains a goal for influenza vaccines. But for the inactivated ones, we don't have it. Large trials of flu vaccine efficacy often use prevention of laboratory-confirmed flu as a primary endpoint, and that's what the CDC does to measure vaccine effectiveness. However, in all of these, lab testing is triggered by the presence of symptoms and almost certainly misses asymptomatic or minimally symptomatic infections that do not prompt a visit. And they said the poor effectiveness of flu vaccines, which ranges from 10 to 60%, is due in large part to our desire to achieve sterilizing immunity as the benchmark. So think about that. Sterilizing immunity, if you get any breakthrough at all. That's kind of a side thing on sterilizing immunity. And from another review article, they said, an optimal flu vaccine would prevent both morbidity and mortality and also inhibit transmission, which currently licensed inactivated vaccines cannot reliably achieve. So far we have this important fact. Inactivated flu vaccines do not prevent transmission. And how do you even look at that? Well, the best way to look at transmission is to do it in a household, because there you know who's infected and who's in contact with who. It's very hard to do transmission experiments and people walking around in the world, right? You don't know where it came from. And in household studies, you can see that the flu vaccine doesn't prevent transmission. Okay. Now, I figured that if in fact asymptomatic people vaccinated people who were asymptomatic shed virus, then the vaccine wouldn't work at all, right? You would never get any protection. So I had this feeling that there must be a level below which if you have very low virus and respiratory secretions, you're likely to be asymptomatic and not have any disease whatsoever. So you're not transmitting. So I asked Florian Kramer this. He was on TWiV 560. And he said, typically people are somewhat symptomatic when they shed. Usually if there are fewer symptoms, there's less virus shedding. There are certainly cases where transmission occurs within vaccinated individuals who have only mild symptoms. We had such a transmission chain at Mount Sinai last year in healthcare personnel. But in general, it's probably pretty rare that virus is transmitted by a non-symptomatic person who might be vaccinated or not. And then he suggests some people who might have data. So I couldn't find papers on this, but here's an expert who says that if you are shedding, you're likely to be symptomatic. And so if there's no situation where you would be shedding enough virus to transmit without having some symptoms that would say, I should work.
So bottom line, that addresses the question in the original letter.
Yeah, it does. A little circuitously.
Right, but good.
There is a household influenza vaccine evaluation study, HIVE study, that's based here at the University of Michigan with Arnold Monto. And Adam Loring has taken advantage of that. There's a paper in 2019, and there's also a paper about intrahost viral diversity that's from Adam's lab from 2016. So I can put those links in.
Yeah, he suggested that Arnold Monto might have some information on transmission from non-symptomatic people. I didn't look it up.
So some of this discussion that we've had about the effectiveness of the vaccine, so what my takeaway from this is that while we say that the effectiveness is not great, one of the things that we're looking for, we set the bar very high in evaluating effectiveness.
Yep.
And a lot of the statistics that you get about effectiveness are not taking into account the fact that those who do get infected and might be counted as vaccinated people who got infected, therefore the vaccine wasn't effective, may get much less severe disease. Okay, so we've set the bar really high. The vaccine is probably, in terms of overall morbidity, perhaps more effective than we give it credit for.
Now,
And it's better than nothing.
it's possible that you get a vaccine and you get a mild influenza. You shouldn't go to work, especially if you're a healthcare worker, right? So if you have any symptoms, respiratory symptoms, you should stay home. But healthcare workers need to be immunized because in the event of a big outbreak, they have to be there to take care of people, right? Okay.
Yeah.
It's that. Well, now since we're talking about outbreaks and epidemics, I thought it would be a good time to talk about African swine fever.
Well, there you go.
Let's give the pigs some attention
Hey, let's do that.
because they're really cute.
They are cute.
cute.
I was going to took the words right out of my
And they're
mouth.
so, well, forget that.
They're supposed to be smart, right?
They're very smart. They're very social.
Mm-hmm.
And they have spread themselves across the entire planet. Because they
With a
tend
little-
to, they
little
get
help from
feral
us.
very
Got help.
easily.
They got help, right?
Well,
Yeah.
yeah, sure. No, we transport them from place to place for a food source, but then some of them get loose.
There's a selective advantage for tasting good.
Yes,
Well,
that's true.
Dickson, maybe civets taste good. We don't know.
It's possible. It's possible. Well, it probably does to the.
Well, there
easier.
are two things you need. You have to taste good, and you have to be able to be raised in large numbers for not, quickly and rather cheaply and so forth, right?
True.
So maybe civets don't fit the bill.
No, pigs, however,
Pigs have a high proportion of protein, right?
and they grow up very fast, and they eat almost anything.
I've been looking for the word because when we were in Bozeman, there's the Museum of the Rockies, which has
Yeah,
just
it's great
amazing
museum.
amounts of dinosaur stuff.
It's a wonderful
And
museum.
I took a picture of the caption of one of the exhibits because they talk about the retaining of juvenile characteristics with age, and that's called neoteny.
Yes.
And then it says the popular term for neoteny is cute in quotation marks.
Right.
So I was glad I saved that.
So there is actually a very interesting paper on the structure of African swine fever virus, which I want to get to. But let's talk about this virus and the disease.
Indeed.
And this is a virus that is causing outbreaks in pig populations, most
Major.
recently in China.
Major outbreak.
We have a couple of articles sent by Anthony. China, 300 million pigs have died.
That's
African swine
incredible.
fever. The U.S. sends to market 100 million pigs a year only.
Only.
And in China, already 300 million. And it's been predicted that a quarter of the world's pig population are going to die.
That's incredible, though, don't you think?
Seoul has culled pigs. That's one way to get rid of the outbreak. All right. So this is a disease caused by a virus close and dear to Rich's heart. An African swine fever virus, member of Asfarviridae, Asfar African swine fever. Asfar. It is also an NCLDV. Right, Rich?
Yep. Nucleocytoplasmic large DNA virus. Think
There you
about
go.
giant viruses. That's what that giant virus meeting was all about.
Okay.
I don't know. I don't recall any African swine fever talks at that
No, there weren't any.
meeting.
Should be.
Okay.
Double-stranded
Should be.
DNA, big. The only virus with double-stranded DNA that's transmitted by arthropods. So, Dickson, you can remember that. You could always ask someone, do you know?
Exactly. This is a cocktail party quiz.
Well, it's the only one we know about, right?
That's right.
Yeah, the only DNA arbovirus.
DNA ARB. So that came up at the giant virus meeting, Rich. I think someone asked the
Mhm.
audience,
Yep.
do you know?
Yep.
So this disease is a very contagious disease. In fact, affects not just domestic, but wild pigs. Doesn't hurt us. Doesn't infect us. Can't be transmitted from pigs to humans. You don't get it by eating infected pork. But it's a threat to pig industry, of course.
We had an episode on African swine fever some time ago,
Yeah.
and I forget exactly what the paper was that we were looking at, but we had a discussion of what the actual natural situation was. And just to review that, there are African suids,
Mhm.
there's certain species of pigs in Africa that are the natural hosts of this thing. And in that reservoir, it's transmitted by ticks.
Right.
And in those pigs and in the ticks, it is asymptomatic. Okay.
Right.
But it's when it spills over out of those animals into domestic and feral pigs or the European wild boar that is lethal, uniformly lethal.
Right.
And the disease also, it has a long history. It was a big problem in the Iberian Peninsula in the early 1900s. And they eventually wound up controlling the disease entirely by culling and killing animals that had the disease and disposing of the carcasses appropriately, understanding how the disease was transmitted, which in the domestic and feral pigs, it can be transmitted by ticks, but also just by contact with contaminated material. And the virus is very stable, so material can be contaminated for a long period of time. So disposing of contaminated material is a serious issue and a serious problem. At any rate, they got rid of the epidemic on the Iberian Peninsula by about 1990. And then, I remember what that episode was about. It was about the outbreak in like Poland and Germany and et cetera. Because in recent years, it has reemerged in Europe and Eastern Europe, and now it's appearing in Asia, which is what this is about.
Right.
Okay, so big problem getting rid of it. There's no vaccine. People have tried real hard for a long time. I don't know what the problems are with the vaccine, but none of the appropriate candidates have been effective.
We talked about it about a year ago, TWiV 532.
Wow.
Was it that long?
January 27th, 2019.
Yeah, I didn't remember that. Wow.
Holy cow.
All you had to do was Google African swine fever virus and TWiV. That's great.
It, in pigs, decreased appetite, weakness, red skin lesions, diarrhea, vomiting, coughing, difficulty breathing. Probably a lot of things cause that, right? In fact, there's another virus that makes similar symptoms, classical swine fever, which is a pestivirus, RNA virus. And I went to read about it, and it's called Schweinepest. Isn't that great? Mm-hmm. Great word, Schweinepest. Dickson doesn't seem to.
I smiled.
If you have a farm and you have pigs, biosecurity is very important. You could easily carry it on your boots to another farm. You have to be careful. That's how it spread. Besides ticks, as Rich said. And if you go to a country that has it, you shouldn't bring back pork products because it can last a long time in pork. So the USDA has some really great infographics. One is about, let's see, I linked to two here. One is about don't spread the deadly disease. It's easy to spread it. And they have a picture of how you could spread it, and report sick pigs. I think that's really cool. And another one is about biosecurity on farms. So, Dickson, when you go to your farm, protect your farm using biosecurity. People can spread disease without knowing it.
I remember this picture from the USDA. It's a cute pig picture.
Cute pig picture. That's right. Then I was wondering, it's appeared in China recently, right? How did it get there? So there's an online newsletter called Pig Progress, pigprogress.net, and they have an article, Where Did China's ASF Come From? So you can go read that. Isn't that great? Pig Progress.
Why are you so amused with that?
Sure. Would you love to be the editor of Pig Progress? What do you do for a living?
Big deals. They're big deals.
I'm making fun, but I think it's great.
I do too.
I love the name.
Listen, I used to work on a trichinosis relationship with pigs that was quite riveting to find out actually what happens to pigs around the world and how they're raised and what they're fed and where they end up. Mm-hmm. And there's another disease called hog cholera. I believe that's a virus as well, which if hog cholera gets into an area, they kill every pig within 100 miles of that outbreak.
I wouldn't be surprised if pig farmers thought that Journal of Virology was a pretty silly idea.
I'm sure. I'm sure.
So according to this article, classical swine fever and hog cholera are eponymous. Is that the word?
The same thing.
Yes.
Yeah, cholera is a pestivirus in the Flaviviridae.
Okay.
It's classical swine fever. Yeah.
But that's
As
not a
opposed to
vector.
African
That's
swine
not a
fever.
vector-borne, or
What?
it's a flavivirus, but it's not vector-borne.
I don't know. Can you see that in your article that you have there, Kathy? Is it
Not yet, but it would be an RNA virus, and we were making a point about it being a DNA virus.
African is the DNA. Classical is the RNA virus. So I found some cool history here. Pigs were initially domesticated in North Africa and Eurasia. They were introduced to southern Africa from Europe and the Far East by the Portuguese 300 years ago and the Chinese 600 years ago.
Just that long ago?
At the end of the 19th century, the extensive pig industry in the native region of ASFV, Kenya, started after massive losses of cattle due to a rinderpest outbreak.
Which is
the cattle died, so they said, let's raise pigs.
Yes.
Pigs were imported on a massive scale for breeding by colonizers from the Seychelles in 1904 and England in 1905. Pig farming was free range at that time.
Right.
And the first outbreak of ASF was in 1907.
Darn.
So there you go. You bring in pigs, you raise them, boom. That virus, which was there already, just infected them. I love this stuff. It's great.
Yep. It is so far, African swine fever has not been in the U.S. commercial market or in the wild. And, this is a big risk. It could come from lots of different there's lots of different threats. Okay.
Yeah.
And
so it could easily be imported. So this is a serious issue.
Rich, I must tell you that the history of pigs and trichinella has a lot to do with the pork industry in Europe, because at one point the U.S. was capable of raising more pigs than they could consume. So they were in the market to find open markets like Europe and Asia as well, but mostly Europe. And in Europe, they were already doing a microscopic examination for trichinella. And as a result, and U.S. wasn't. So they had an outbreak in some part of Germany at the turn of the century, and they blamed it on U.S. pigs that were brought in clandestinely. Because there's an underground pig market also, by the way, which allows pigs to go in lots of places where they obviously shouldn't.
It would be hard to smuggle.
So what happened as a result of that outbreak in Germany was that all of Europe banned any importing of pigs from the United States. So we became sort of like a null hypothesis with regards to the spread of diseases, because if we can take them in, but we can't bring them out. Okay, so if your trade agreements don't have reciprocity, then the pig industries seek other ways of. It's complicated stuff. Basically, it's like bulls and
I don't think we currently import pigs.
We don't. No, we don't.
We export a lot to China.
Well,
places. China is a huge importer.
Japan also, and to other countries that don't have the capacity that we have, and so a pig is.
I'm surprised it's not here yet, because you don't need ticks to spread it, obviously.
But we don't import a lot of pigs as a result of these agreements that we have now. And I dare say that the China pig agreement between the U.S. and China is not valid right now because of all these tariffs that have been put on other goods.
This also has implications for influenza, because pigs are infected, and this pig trade has impacted the spread of influenza virus.
Exactly.
Amy Vincent. Do you remember that name, Kathy? Amy Vincent. She was at ASV.
Isn't that Amy and Vincent?
She's interested. She talks about the spread of influenza by pigs, and she thinks the next pandemic strain will probably come from pigs. Go ahead.
When you travel abroad and you come back and you fill out your immigration customs form,
that's right.
They ask you questions like, have you been to a farm?
Yeah,
correct.
And they ask you for details on that, and this is why.
They do.
I mean, not just African swine fever, but this is one of the reasons why.
I lost 3.5 pounds of chorizo once coming back from Spain.
I'm glad you could have been the cause.
No, but it was a cured meat. They don't usually have a regulation about that. They don't. This was
Vincent, I'm a little puzzled, because I think I'm remembering Martha Nelson about influenza and pigs. When pigs fly? Is that a different story or from Amy Vincent?
So Amy Vincent, this year there was a morning speaker on, I think, the last day at ASV who talked about this. I don't know if it was Amy Vincent or someone else.
Well,
who was Amy Vincent on the program?
No, that's why I'm confused.
I find this curious.
Nelson,
Did she talk about when pigs fly?
She talked on the last.
Okay, so I think it's the same group.
Yes.
But I heard Amy Vincent at a satellite, I think, maybe at Fort Collins last time. She talks about the same thing. But it's this idea that pigs are big in the spread of influenza viruses because they get infected from birds and from humans.
And another thing to think about here is the protein loss in a diet for our whole country with 300 million pigs just lost all at once.
I know.
That's an enormous loss of food.
Well, the Nipah outbreak in Malaysia, they culled over 1 million pigs, and it's not for that country, that's a lot of protein.
Yes.
Mm-hmm.
Yes.
Right.
Yes.
So, yes, I mean, depending on one source of protein
That's right.
It's hard.
So that might have triggered.
And at this point, culling animals and disposing of them properly is the only way we know of to control the disease.
Yeah,
This is all
exactly.
true. So imagine a country like China that suddenly is protein deficient. It says, okay, go out and find some more protein. And then the next thing you know, you've got this new coronavirus.
It's a problem. Yeah, it's a problem.
So they
So what do you do? What's the solution, Dickson?
Well, I learned by making a mistake on one of our shows that 60% of the pigs of China are raised indoors.
Yet they still have this outbreak.
Exactly. So the indoor barriers are not as good as they sound.
Well, I think if biosecurity is the key, right?
That is
Maybe
the
it's
key.
not very good. I don't know.
Is the key. So
you don't let people in with boots from the outside. You have to change.
So
example,
in their case, the P1 stands for Pig Number 1 facility to make it safe.
Well, I think people are working on a vaccine, but Rich, you said it hasn't been much
No progress so far.
You're going to make a lot of money.
No progress. I recall. So one of my contacts on this is a woman named Linda Dickson, who works at Pirbright, which is the animal health facility in the UK. And I asked her numerous questions, among them the vaccine question, just to follow that up. And my recollection is that her answer was, "Sorry, dude, we're trying. A lot of people are trying, but no progress so far." And I don't know what the hangups are. I'm not sure they know what the hangups are either. But all of the typical approaches that you can think of, live vaccines, engineered vaccines, subunit vaccines, these have all been tried, and nothing's working.
Maybe it's how you give the vaccine.
Don't know why.
Right? Because, I mean, this sounds like a respiratory oral thing.
Yeah.
And if you inject something, maybe that's going to avoid the immune response that you need in order to get protection.
I will, even on the side here, search my email and see if I can find your correspondence.
So the paper about African swine fever virus is pretty cool. It was published in JBC. The cryo-EM structure of African swine fever virus unravels a unique architecture comprising 2 icosahedral protein capsids and 2 lipoprotein membranes. 2
per virus.
2 something. What is that old ad? 2 tastes and 2 gums.
Yeah.
It's a breast mint and a candy
double
mint.
Yeah.
Double mint.
Yes. And there are 2 co-first authors, German Andres and Diego Charo.
Matamoros, Dillard, and Abrescia. This is from the Universidad Autónoma de Madrid, the CICB Biogun, which is also in Spain, Leiden University, and the Basque Foundation for Science.
Basque Foundation, really?
Mm-hmm.
Yeah, Iker Bas.
Oh, interesting.
Mm-hmm.
This was done by single particle cryo-EM.
And
it's
an amazing structure stuff.
It's I don't know if this is open access, but it is.
It is
beautiful. Go look at the pictures because they are gorgeous.
Right now.
So this is quite a large virus. It has this outer envelope, which is acquired as the virus leaves the cell. And it's
kind of random shaped.
It's random shaped. It's not symmetric, right? And then there's a capsid beneath that envelope, and they got a 23 angstrom resolution structure, which measures 2,080 angstroms in diameter.
Also known as 208 nanometers.
208 nanometers. And then underneath that capsid is an icosahedral membrane.
Oh.
And they can see the outer and inner leaflets on the cryo-EMs. And then beneath that inner membrane is a second icosahedral capsid, in which encases the DNA, the core shell, and the nucleoid. It's just great. Mm-hmm. So it's a large virus similar to a lot of these other NCLDV. It's icosahedral. They're not all icosahedral, right? Pox viruses are not. Pandoras are not, but some of them are. A little bit on the structure. The outer capsid, and this will hark back to the structure of Cafeteria roenbergensis virus, which we talked about last year, which was done in Rivers' lab in UTEP. You remember that one? Mm-hmm. He actually wrote in afterwards, was excited that we had done his paper, which took him many years to do that structure. It's the outer shell is made up of a major capsid protein, P72, which has a double jelly roll fold. This is a very common fold among capsid proteins, and that makes up the outer shell. And this is arranged in trisymmetrons and pentasymmetrons. These are ordered collections of capsomeres that make the facets and the vertices. And we introduced this in the Cafeteria roenbergensis virus structure. It's very unusual. And in fact, the way these assemble is by a spiral mechanism that River has proposed. Remember that, Rich?
Yep.
Spiral assembly. And it's unusual. Let's see what else. Then you have underneath it is an icosahedrally ordered membrane, which is about 34 angstroms thick. And then there's another capsid underneath it, as I told you. That's about 1,500 angstroms in diameter. Of course, within that is the DNA. This capsid is interesting because they're turrets at the apices of the capsid, which they say indicates the presence of a specific penton protein. That's a 5-fold axis there. And they're beautiful, beautiful pictures here in the paper, which you can see all of this. And then inside, of course, is the DNA. And this is very similar to Fausto viruses, which is a lovely name, right, for a virus family, which has a similar particle, has 2 capsids, but no internal membrane. So this is unusual because it's got that membrane in between the two. Go ahead, Kath. Yeah. Sorry.
Well, I was just going to say that the end of the abstract left me thinking that we were going to learn a whole lot, because it said this confers the unique architecture that likely reflects the complexity of its infection process and may help explain current challenges in controlling it. And, it's got kind of a short results section and then a discussion section. And I just was kind of left with not having much information about how the virus assembles, right? How the virus assembles. And, well, the challenges are, in terms of vaccinating against it, maybe because the virus is so protected, the genome is so protected, and so you don't get innate immunity because the DNA isn't getting out and so forth. But I just was left with, well, where does it get that membrane, and where does it get that other membrane? And didn't get.
So I have a tendency to look at all of this through pox-colored glasses. Okay. And I find significant parallels between this and pox viruses, which may be illuminating in this regard. Mm-hmm. We used to, before the giant viruses showed up, the large cytoplasmic, or at least partially cytoplasmic DNA viruses consisted of iridoviruses, which are only part of their time spent in the cytoplasm and are icosahedral, and African swine fever, which spends all of its time in the cytoplasm and is icosahedral, and pox viruses, which spend all of their time in the cytoplasm and are brick-shaped. They don't have the icosahedral symmetry. So I used to think of African swine fever virus as a pox virus in iridovirus clothing. And this really kind of reinforces that. Okay, so the pox viruses don't have any of this icosahedral symmetry, but they have a core that importantly contains the DNA and all of the transcription enzymes for carrying out early transcription phase in the cytoplasm. And the wall of that core is a really tough structure that in pox viruses we really don't understand. And surrounding that core in the pox viruses is a membrane. So to me, the wall of that core in the pox viruses is the equivalent, though there's no either structural or genetic homology between the inner capsid in African swine fever. To me, there's some sort of functional equivalence there. And they do talk about this some in the discussion section where they say that in the African swine fever infection, the virus is internalized by endocytosis, and the acidity dissolves, the acidity of the endosome dissolves the outer capsid, whereupon the inner membrane can fuse with the endosome membrane to dump this core that contains the inner capsid in the cytoplasm. And then they go on to talk about how maybe the DNA is shielded from DNA sensing cellular immune responses. This is precisely equivalent to pox viruses. Mm-hmm. Pox viruses don't have the outer shell, or they don't in the mature particle. I'll come back to that. But the equivalent of the mature pox virus has on its outer surface the equivalent of the inner membrane, which in the case of pox viruses plays a role in the uptake, and ultimately equivalent to ASFV, the release of this core particle into the cytoplasm. So I think that there's a lot of equivalence there with this inner structure, this core particle being a little transcription machine that is otherwise shielded from the intercellular environment and makes RNA and probably pumps it out into the cytoplasm for protein synthesis. So the big difference there is, structurally the proteins are different, in that inner capsid has in the case of African swine fever, an icosahedral symmetry, but there's a functional similarity. And then there's in the case of the pox viruses, there's an equivalence where the outer capsid of African swine fever virus that is shown in this beautiful structure in this paper is this double jelly roll protein that's one of the few virus proteins that's conserved throughout the NCLDVs. Mm. And in the case of pox viruses, that's this protein D13, which forms, rather than a icosahedron, more of a spherical structure that's a scaffold for making the virus membrane. That's the equivalent of the African swine fever virus inner membrane. The difference is that in the final maturation of the pox viruses, the D13 is disposed of. So you don't have the outer shell. Whereas in African swine fever virus and most of the other NCLDVs, that major structural protein is retained as a structural protein that's probably involved in, transmission and in infection of the virus. The outermost membrane that's picked up by budding through the plasma membrane in the case of the African swine fever virus, there is an equivalent in the pox viruses as well that's acquired by budding through the Golgi apparatus. And there's a small percentage of pox viruses pox virus yield that has this outermost membrane. And they point out in this article that both the membraned and the non-budded form, the non-outer membrane form of African swine fever virus are infectious, and the same holds for pox viruses. So the outer membrane is equivalent as well. So I would say that there's a lot of functional equivalence, even though structurally they look different in the pox viruses and the African swine fever. And in my mind, the way I look at it, of course, I'm really biased here. The pox virus life cycle gives me insight into how these structures operate in the African swine fever virus infection. I think one of the huge differences is that the outermost capsid in the African swine fever virus is retained and probably plays a primary role in the attachment of probably preservation of the virus in the environment, because after all, it is a very stable entity, and also the uptake during infection.
In case you're wondering what a jelly roll is, it's also known as a Swiss roll fold. It's a protein fold made of 8 beta strands arranged in 2 4-stranded sheets. The name was given in 1981 by Jane Richardson because she thought it looked like a jelly or Swiss roll cake. And it is very common. It's in about 30% of all the proteins that have been studied. Very common fold, so something is good about it. The other thing I think that this paper tells us, Kathy, about maybe control is that maybe you could start to see the epitopes that are important for making neutralizing antibodies. They mentioned in the last paragraph that you can take off the outer membrane of this virus and the virus is still infectious. And in fact, antibodies against the major capsid protein mentioned, P72, are neutralizing. So this is kind of, it may explain why they are neutralizing, right?
Right.
So you don't need to have that membrane. So maybe people can identify now epitopes and see where they are on these proteins.
Do they know what the receptor is here?
I don't think so. I'm not aware of it.
No.
They didn't mention it at all.
Okay.
Would you like to identify it, Dickson?
I'd love to. I mean, I'd like to see this thing go away because it's causing such havoc among lots of other things, including economics, political unrest, food acquisition by underserved people. Pigs are kept as pets and then eaten in many places because they do eat everything. So they'll eat what you have left on your plate, which you shouldn't have anything if you're living in a marginal situation. But sometimes when you prepare food, there is stuff left over, like you shuck corn, and
yeah, sure,
pigs will eat that, no problem.
Well, my family my father's family in Italy, they live way out in the country. They used to raise a pig every year.
Yeah, sure.
It was outside in a place.
Yeah.
And they took all the kitchen scraps, they put it in a bucket,
exactly,
and then they would feed it to the pig, and then in the fall they would slaughter it and then cure the meats and all this stuff. You know?
Yep.
I loved visiting in the summer. I would always go and look at the pig and talk to it and give it food scraps.
Sure.
I always saw it alive, you know.
That's right.
But you would bring it a bucket. It was like,
oh no,
they're eat like crazy. I have fond memories of those pigs.
And they're big survivors. They become feral very fast.
So I found a couple of things here. I found what appears to be a really nice article from The Scientist. I pasted a link into number 15 there on your bullet list of comments, Vincent, that talks about the development of vaccines for African swine fever, or the attempts at doing it. And apparently, the thing that's most promising is directed engineering of the genome. Okay, trying to delete genes to cripple the virus in an intelligent way. But those, there are promising candidates, but there's a lot of development yet to be done. But this is a nice summary of the problem. Also, as part of that, there's a quote here from the woman I talked about, Linda Dickson, that says African swine fever virus infects and replicates in macrophages, but also induces cell death in uninfected B and T cells, effectively wiping out the immune system. So there's not an effective response. So that, my guess is that complicates things.
It does.
And I looked up my correspondence with Linda from that last episode that we did, and I was fabricating a memory about vaccines because there's nothing in there about that. However, she does say, at the end, she says, my final comments are, if you want a pig industry, you have to control African swine fever in the wild boar. This is in particular in, I don't know how bad a problem this is in China, but in Europe it's a problem.
Yeah, I would say.
Currently, currently, targeted culling seems to be the only option in the future when we have a vaccine of wild boar using baits that should help control the disease. But the fact that this is running around in wild boars in Europe really complicates the problem, because you can't just cull on farms where you're observing the pigs and seeing them get sick. You have to somehow control the wild population, which is tough. I mean, they talk about hunting and all kinds of things like that.
Maybe we need to vaccinate the wild boars.
Well, that's what she's saying. When we get a vaccine, use the same approach that you did in rabies in the U.S., which is to put the vaccine in bait and distribute it in the wild. And that we already know from working with rabies, that can be an effective strategy if you have a good vaccine.
I remember this boar conversation now.
Mm-hmm.
And also, the scientist
That's
article is really
not boring. Right?
Yeah, this is really great because it has a cute picture of the pig right at the start, and it has really pretty colored, false colored pictures of the African swine fever virus.
Mm-hmm. Yeah, it's a good article.
So it's nice. Yeah.
Boars. I remember I did a TWiV in Switzerland, I think last year or the year before, and my guests was into hunting boars and eating them.
Mm-hmm.
But there was some virus infection, or maybe it was trichinella. I don't remember. He was worried about. I said, "So what do you do?" He said, "I do PCR before I eat it." Isn't that funny?
That is very funny.
Can you imagine? Get some meat, do some PCR.
Yeah.
Actually, you're right, Kathy. This picture of the pig on the scientist is particularly amusing because he's obviously been rooting in the mud.
Yeah.
He's got dirt all over his face. I think he's smiling.
Yeah,
too.
he is.
Yeah,
His face is all muddy. He doesn't care. Nice eyes, though. It's cool.
Yeah.
He's looking at him. Okay, let's do a couple of emails. I have one from Les who sends a link to a coin that's available from the U.S. Mint celebrating polio vaccine 1953. It says, I guess, American innovation, which recognizes individual states. So this is Pennsylvania. Of course, Salk worked at University of Pittsburgh. Mm-hmm. And it's a lovely coin with a microscope and a polio virus, icosahedral particle, polio vaccine 1953. And you can buy it. It's not that expensive, actually. I think I should probably get one. It's $1.
Yeah.
Mm-hmm.
$1?
It's $1.
Yeah.
Isn't it? Or wait, $1 reverse proof coin, $9.95.
Right. No, and there's probably $25 in shipping.
Exactly.
So it basically,
if you order now, you get two.
I wonder how big this thing is. Is it like a penny size or something? I don't know.
Oh.
So these are meant to celebrate innovation in states.
Right.
And they will mint 75,000, and you can buy them all if you'd like. Household order limit is none.
Is that the right shape for poliovirus, Vincent?
That's an icosahedral particle, right?
Right.
I mean, it's not actually that shape. It's spherical, as you can see on the desk.
Yeah, well, I was going
right?
to... That's what I'm saying.
Its diameter is 1.043 inches.
Oh, it's tiny.
Because you think
quarter.
metric, it's 26.49 millimeters.
Yeah. So it's bigger than a penny, right?
Yeah. It's almost...
I'm going to get one.
I would get several.
Yeah.
You would?
Figure out what the shipping
In case
is
you
and
lose
how many
it.
you can get for one shipping.
Maybe I should get a whole bunch and give them out to everybody.
Wouldn't that be great?
I wouldn't mind doing that. Sure. Kathy, can you take the next one? Sorry.
In a moment. I was on the page. Okay, sure. Robert writes regarding Paula Stefan TWiV, a very interesting podcast on an important topic that is hugely neglected. I got my PhD in 1973, a time when Dr. Stefan, or is it Stefan? Stephen? I don't know. Pointed out a vast change was taking place in the academic job market. I had a hard time of it. My academic travails in the pursuit of my degree didn't help a lot, but probably a picnic compared to what people are experiencing these days. Mm-hmm. I attribute a lot of the problems in the U.S. academic scene to the crass American disdain for intellectualism. Mm-hmm. People with some knowledge and learning are not thought much of compared to, say, sports or entertainment figures. Eggheads. For example, after the latest economic crash in 2008, K-12 school teachers were being shed by the load from strapped municipalities. If these people had been thought to be doing something valuable, oh, wait, they're only educating our kids. A program could have been put together to keep them employed in schools for the duration, and we would all then reap enormous benefits in times to come. Nope, can't spend our tax dollars on stuff like that. Some billionaire might be forced to pay a nickel more on his or her tax bill. Regards, Bob.
So this is so well discussed in Blowout, the book I just finished by Rachel Maddow. It's all about the oil and gas industry. And she focuses a lot on Oklahoma, which historically always gave huge tax breaks to these companies. And they found themselves not having any state income, and so the schools were in complete disrepair.
Great.
And only finally the teachers and the parents got fed up, and they threatened to vote out the people who were putting these breaks in, and they restored some income to the state, did this change. And it's all to protect this big income, right? And the thing is, after a while, they didn't need these breaks anymore because there was no more exploration, which originally was meant to stimulate. Yet they had so much power, and if any politician wanted to go against it, the oil companies would come and lobby and blah, 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 and so forth. And her thing at the end is that, we can change. It's up to the voters. The voters have to make the change.
You bet.
It can be done. But this is the 2008. In fact, the recovery from that was largely propelled by fracking and gas. It's amazing. Good book. Read it. Thank you, Bob. I think it's pronounced Stefan, Kathy.
Yeah, I remember listening to that TWiV now. It was TWiV 574 back in November from Georgia State, The Economist. Yeah.
Rich, can you take the next one, please?
Yeah, if I can find it. Let me see. This is Avijit writes, Dear Sir, I am Avijit from Bangladesh. I completed my post-graduation in microbiology. Now I am searching for a PhD position, but I don't have strong research paper. I am quite pressured in my future career. Can you advise me what I can do right now? Please respond to me if you have time. I'm a big fan of you. Yours obediently, Avijit. So I'm a little confused here because he says that he's completed his post-graduation in microbiology. That implies to me some sort of advanced degree, not just an undergraduate degree. But he says, I'm searching for a PhD position. I'm not sure whether he means he wants to get into a PhD program or is looking for a postdoc.
I assumed he was looking for a PhD program.
That seemed to me the more likely. In either case, it's just basically you got to apply,
So, I was thinking when I was applying to graduate school, you didn't need any papers to get in. You just had to maybe have done some research or shown some aptitude. But now I think the bar is different. I think
you think so?
Kids in high school are getting on papers, right? So maybe it's tough. Maybe the competition. I don't know. I'm not, in tune with what is going on there. But I mean, I would have said get a job in a lab where you can do some research. Maybe not a PhD program, but where you can get a paper if that's really important. I don't know if what people think now, if that's important or not.
Kathy, you must still have, experience with admissions committees. The people applying for PhDs for a graduate school have research papers?
Oh, not. It would be more unusual to have it than not. But I mean, there are people who do come in with papers, right. But they're not usually a first author paper either. They're so yeah.
So it seems to me that if you're looking for a PhD position, all the programs that have PhD programs are publicized, and you can just apply. And I don't think in that case having a research paper is that big a deal. If you're looking for a postdoc, it's a different story.
Yeah, of course.
Okay. I find the ambiguity in this, to be honest.
Mm-hmm. Yeah.
Because it says, I am now searching for a PhD position, a position of a PhD to now go and do the next step in his career. That's what That's what I'm thinking about. Because that's why he says that I don't have a strong research paper.
Right.
Because he's already done his research. So now I'm quite so do a postdoc. That's the advice that you could give right away if that's the case.
Well, he or she is saying that I don't have a good, strong paper to get me a postdoc. I think.
Well, there are a lot of places that sort of need hands on boots on the ground, so to speak. And they make exceptions for people with, well, it's not a strong paper, but at least, do you know what a pipette is? Yes. You can sit right over here. And, I know places like that.
But, also in Bangladesh, it may not be.
It may not
be so many opportunities, right?
No, that's also true. That's very true.
So it's hard. I can understand. But I mean, I would say if you're looking to get into a PhD program and you need papers,
that's different.
Then you need to get a job in a lab where you can get some. There's no solution other than that, right?
Unless you want to move.
Right.
Or you could move, yeah.
Right. Talk to your teachers or your professors and see what they can see.
Exactly.
I love that he or she put a little bunch of hearts here.
Yeah.
Yes. Yeah.
That's true.
It's my research says it's a male name.
Okay.
Dickson,
can you take
yes.
Carol's?
Carol writes, update on Samoan measles scare, and then she lists a link.
Washington Post. Did you know, Dickson, there was an outbreak in Samoa?
Yeah, I did know that, actually. I've been following that quite carefully.
Some kids have died.
Lots of kids have died, not just a few, a lot. In this Post article, RFK Jr. was named as one of the parties who tried to get politicians in that country to question vaccine safety on the island. This report also mentions that there were nurses that faced medical malpractice in the vaccine preparation that led up to the measles scare on the island. This is now another case where vaccine has become a major political issue, and this time it's not just from within the United States. You want me to read the next one?
Sure.
Also from Ryan, and there's another link to another article about the same subject. These deaths from the measles scare is being reported to be pointed at RFK Jr., and some anti-vax leaders had a meeting in with Samoan officials over vaccines as the point of origin of this outbreak and the allegations. Also, a CDC investigation is at play here. The problem here is that we have been going after Andrew Wakefield, Del Bigtree, RFK Jr., and Bernard Seltz for trying to sway politicians here in the United States for the measles scare here at home. Now a new allegation is at play, showing that these same people are named in the political backlash and scaring parents for measles disasters in other countries too. And then there's something from you, Rich. Do you want to read that?
The important thing is that he links an NBC News article that I mentioned at the top of the show that I think is just an outstanding article because, among other things, it talks about what always gets to me is the motivations of the individuals at the peak of the anti-vax community. And just to quote from this article, just one such example, there's a guy named Cook, says, since 2015, Cook has made a business out of the anti-vaccination narratives of distressed parents. He has raised over $100,000 through multiple GoFundMe campaigns, and then via other platforms after GoFundMe banned him in March. Cook has his own Amazon storefront where he promotes anti-vaccine books and films, taking a cut of the sales, and raises an unknown amount through his website, accepting donations through PayPal that go directly to me, according to his website. And my comment is that these people should be prosecuted. The NBC News articles talks about a particular case where some woman's child died effectively of SIDS. The infant was co-sleeping with the mother and was found dead in the morning, and the autopsy report said that the child had suffocated. And she sort of publicized her grief on Facebook, and the anti-vaxxers came after her and said it wasn't suffocation, it was vaccines. Your kid was vaccinated right before this, right? Okay. And this woman was taken in, okay, and now has, she's making money too because she's got her own GoFundMe stuff going on. But she has become a poster child for the anti-vax campaign saying vaccines kill kids. And they do this. This is not just an isolated example. The anti-vaxxers find people who have lost kids to SIDS or other things that where it's not an obvious infection. It's just a sudden death. and they exploit them to advance their anti-vax agenda. I think these people should be prosecuted. They're causing, I mean, it's not just the usual scam, because people die because of this. All right? They're promoting conspiracy theories and myths and pseudoscience that results in people ultimately dying because they're not getting vaccinated. These people need to be prosecuted. This is just disgusting. And it's a really good article that describes this. I don't get worked up about this at all.
Yeah, I agree.
No,
I agree.
I wish
But at some point, it should be a crime.
Richard, you should take a stand on this, I think.
Oh, he just did. He just did.
Well, I was joking, Vincent.
It's not going to end anytime soon. I mean,
No.
you know,
It's been going on forever. The thing that gets me is, there's been snake oil ever since there have been humans, okay?
And snakes.
And phony science and all sorts of phony health remedies and all the rest of it. But the problem is that this is killing people. Okay? If you want to throw away your money or waste your life on a conspiracy theory, fine. But if people are getting hurt, that's another issue.
yeah, I don't get that part. I get if you want to make money, snake oil, but hurting other people doesn't make any sense. I don't get it. Well, let's do some picks. Rich, what do you have for us?
I have a nested pick on the Mayo Clinic. It starts actually with what I've listed as number 2 here, which is a website. It's the Mayo Clinic website. It's actually a subsite on their site called Patient Care and Health Information. And this is a public service announcement, really. I find that this Mayo Clinic site is one of the best resources out there for information on healthcare stuff of one sort or another. And they have a bunch of different tools in this. You can look up diseases or symptoms or tests and procedures or drugs and supplements very easily on this website. And it's very intelligent, very readable, and I think very reliable. So if you got questions about this or that disease or this or that test or some symptom that you have, I think that this is an extraordinary resource. And it also has information on wellness, for example. I use this all the time, but I came across it recently because my daughters gave me a Garmin activity tracker for Christmas. Right? So now I know. So now I know what my pulse is all the time, and it got me interested in. It got me interested in exercise and heart rate. And so I went to look at what maximum heart rate meant and all this kind of stuff. And boom, up popped the Mayo Clinic with a beautiful discourse about how to calculate your maximum heart rate and what appropriate exercise levels were relative to heart rate, et cetera. So at any rate, I think that this is a great information site. Along with that, I was reminded that there was a Ken Burns documentary made not too long ago about the Mayo Clinic.
Right.
And I put in a link to that. And it's, as most Ken Burns documentaries are, it's outstanding and gives you real insight into what medicine should be. Because the Mayo Clinic is, to me, what medicine should be. So I recommend that.
No, they even have polio here.
There you go.
Diseases.
Absolutely.
Let's see if they have AFM. What do you think, Dickson? Think they might have?
Oh, yeah, sure.
They're in Minnesota. They should. Yeah, they should.
AFM. Wow, there's a lot of C's and D's. I'm still scrolling. D's.
Well, you can also just use their regular search.
Yeah, just curious when you hit the alphabet.
Yeah.
Acute flaccid. Where's the F? Acute. They don't have AFM.
Because it's a pig disease, not a human disease.
No, that's not AS. I'm not talking about African swine fever. I'm calling it acute flaccid myelitis.
Oh, that.
Dixon, what do you have for us?
I've got 3 related picks. Well, they're visual more than verbal, but the middle one is verbal. And that attracted my attention first from the Science Times this week that had a big article about the effects that the fires in Australia might have on exotic insects. And Australia has a lot of those. and it shows these beautifully colored grasshoppers. And they can't fly very far, and of course they can't escape these horrible bushfires, as they're calling them. They're almost contiguous down the entire coast of Australia. I said, how bad can it be? Come on, they're talking about this. I was in Australia for 6 months. I know about fires there because they talked about them while I was there and everything. But then I went to the NASA website and I saw actually where they are, and it's amazing that how much of burnable Australia is on fire. Because there's just this thin green line that goes down the east coast of Australia, and it stops somewhere around Adelaide, and then it becomes all desert until it gets back over to the other side. And there's not much foliage in Australia, and it's all concentrated where the mountains are, and the mountains are all on the east coast. So now you've got all of this particulate matter and smoke going out over the Pacific Ocean, rather. It went directly over New Zealand. That's the third feature here. It shows you the path of the smoke and the aerosols. And that has huge effects on land masses and the way animals behave and the way plants behave and everything else. And I got to thinking, this is really going to alter permanently some ecological relationships. And it may even cause the extinction of some animals.
Of course.
And it's a horrible situation right now. And I just thought that, I wonder what this will do to the Kendra viruses or the other viruses that you're concerned about. That
they're in bats. If the bats are gone, there'll be no more viruses.
I mean, the bats can fly, but they can fly. So where are they going to fly to? That's the problem.
Well, the organisms that can survive will proliferate, right? The ones that can get away or that can survive the heat and so forth.
You notice on the fire charts that the NASA lists that it stops somewhere just below Brisbane. And there's a whole jungle section to Australia, which is north of that. And apparently they're not getting the same weather patterns and it's not as dry up there, but it's horrible.
There are 250,000 insect species in Australia alone.
Yeah.
Wow.
Those blue-green iridescent grasshoppers.
Yeah, they're beautiful.
Really pretty.
They're gorgeous little, and they're rare. They're obviously not found anywhere else. They're endemic, and so this is going to have a huge amount of permanent effect, unfortunately, on them.
It's amazing to think that Australia is as big as continental U.S.
Exactly,
and there's a significant fraction of it that's on fire.
That's right, and the rest of it's all desert. It's just like
amazing. The population is, what is it? 10 million?
It's only 20. No, it's 23 or 24 million. But this raises the last question I'm going to talk about, and that is, where is their food going to come from? Because that's where all the farming occurs.
They need to make indoor farms.
They're doing that, by the way. They are doing that, but they're not going to
a lot of land.
They're not going to do it fast enough to avoid the effects of this, I'm afraid.
Because they raise a lot of pigs.
They have huge numbers of feral pigs. Don't you remember from what the hell's the name of that movie? Crocodile Dundee. In that movie, they actually showed guys in jeeps with machine guns up there killing not only kangaroos, but also wild pigs. They have huge numbers of wild pigs. Not anymore. And the cane frogs, maybe those will go too. Who knows? But so.
Yeah, it's very sad.
Yeah.
Is it going to stop?
Of course.
It'll burn out?
It'll always stop.
At some point?
Yeah, of course it will. And then nature will take over again, and it's resilient. The people may not be, but the nature part of it sure is. Be interesting to see what happens over the next 100 years.
Kathy, what do you have for us?
I have something completely different, very light. I get a word a day email. I've gotten it for years. And the word I picked is back from September, I think, runcible. It's a noun and an adjective. As a noun, it's a utensil that's a combination of a fork and a spoon, also known as a spork. So there's a little bit of debate about the etymology. As listed here, it says that Edward Lear coined the word in the poem The Owl and the Pussycat. They dined on mince and slices of quince, which they ate with a runcible spoon. And what runcible meant was left to the imagination of the reader. Anyway, then if you go on a little bit further, they've said if a spoon and a fork mate to give a runcible spoon, a runcible or a spork? What happens when other pieces of cutlery get together?
That's
and so
a good
you click
question.
on that analysis, and there's kind of this Venn diagram of like a knife and a spoon. It gives you a spife and so forth.
Right.
So anyway, just something light and fun.
Could I have this texted to me every morning? They should have a service. I would
You
love
can
that.
get it. You get it emailed. You get it in your
You
email.
get it
every
emailed?
morning. Yep.
So shouldn't this
Yeah.
be etymology rather than etymology?
Yeah, right. In this case, maybe so. Yeah.
Arg.
Yeah.
It's cool.
Yeah. Well,
Today's-
it's funny that you'd say that. His name is Anu Garg. Yeah.
Today's word is indicate.
Indicate.
Indicate. You know
Spell
what
it.
that means?
Yeah. No,
I-N-D-A-G-A-T-E.
my car ran into gate.
No. INDAGATE. To search into, to investigate.
Right.
Indicate.
Yeah.
If I
this
used
week-
it, nobody would know what I was talking about.
You're
Well,
absolutely
and this
right.
week is unusual synonyms. So the first word this week was ombrifuge, which is just another word for umbrella.
Oh, come on.
Yeah.
Some of them are too obscure.
Yeah. But each week, it's great. You can subscribe.
I have a pick, which is a opinion by Peter Hotez
Right.
in the New York Times, which
Yes.
our colleague Charles Knersh sent to us yesterday.
Yep.
You are unvaccinated and got sick. These are your odds. Comparing the dangerous effects of 3 diseases with the minimal side effects of their corresponding vaccines. And it's wonderful. But as I wrote to him yesterday, everyone reading the Times is pretty much bought into this. You need to find the Fox News people who are not and reach them. But it's great. It picks a couple
Really
of
good
diseases and
graphics.
great
Yeah.
graphics, blah, blah, blah. But gee, oh well. I wrote him and he said, "It's your job."
Yes. So,
I don't think so.
Yeah, I wrote it.
well, it's out on Twitter too, but that it's going to be in the Twitter streams of the people who
Yeah,
are
exactly.
pro-vaccines. Yeah.
All right, that is TWiV number 582. Please subscribe on your phone or tablet. If you do, you will get every episode for free, and we will know how many people are listening that's useful to us. And all the notes, the links that we talk about are at microbe.tv/TWiV. As I mentioned earlier, we'd love your support, your financial support to help pay our expenses. Microbe.tv/contribute. We have mechanisms like PayPal and Patreon where you could give as little as $1 a month. Kathy Spindler is at the University of Michigan in Ann Arbor. Thank you, Kathy.
Thanks. This is a lot of fun.
Rich Condit is an emeritus professor, University of Florida, Gainesville, currently residing in Austin, Texas. Thanks, Rich.
Sure enough. Always a good time. This is especially good. I got nice and worked up about both the science and the social stuff.
Dickson Despommier.
Yeah.
Racaniello.org and livingriver.com. Thank you, Dickson.
Yep. Terrific.
Thank you for coming in.
That was fun.
I'm Vincent Racaniello. You can find me at virology.ws. Thanks to ASV and ASM for their support and Ronald Jenkins for the music. This episode was recorded, edited, and posted by me, Vincent Racaniello. You've been listening to This Week in Virology. Thanks for joining us. We'll be back next week. Another TWiV is viral.